Okay, everybody. My name is Margot Buckles. I am a volunteer with WASBA, and we are presenting Ask a Washington Beekeeper. Tonight we have with us Dr. Dewey Caron. He is the Emeritus Professor of Entomology and Wildlife Ecology of the University of Delaware, and he's an affiliate professor and content communication specialist, Oregon Master Beekeeper Program, Department of Horticulture, Oregon State University. The more interesting stuff from his bio is that he had 2 Fulbright Awards for Africanized bee projects in Panama and Bolivia. And when he retired from the University of Delaware in 2009, he moved to Portland to be closer to his grandkids, and he is now a backyard beekeeper in Oregon. He continues to remain active in bee education, and he spends 3 months annually in Bolivia with family where he keeps Africanized bees. He's the author of Honeybee Biology and Beekeeping, the Complete Bee Handbook, and the major author of several Honeybee Health Coalition publications, including Tools for Varroa Management and Hive Health BMPs. It says he's currently completing a USDA APHIS BMD web program. This program is sponsored by the Washington State Beekeepers Association in conjunction with GRUB, which is a farm veteran organization. And I'm just going to let Dewey get started. But before I do, please put any questions that you might have in the chat, and we will answer them at the end of the program. Dewey, go ahead.
All righty. Thank you, Margot. Appreciate the introduction. And thank you, Ken Curtis and the Cowlitz Beekeepers. I was scheduled there this evening, so we're actually doing dual. We're doing their meeting. Hi, all my acquaintances in the Cowlitz group and across Washington. I'm going to talk about CSI. Dead hives have a tale to tell. Do they, in fact, have that tale? If we don't get the question answered, I have my email. I use Delaware. You can get me at Oregon State as well, but it's Caron D at Oregon State edu. Sometimes I wonder if my bees are thinking about me too. This is National Ag Week. Tuesday was National Ag Day. In some circles, we are considered to be livestock for the larger scale beekeeper, certainly, although many of us would not think so. So, Happy National Ag Week. I run a survey and have now for the 15 years since I've been on the West Coast that includes Oregon, Washington, and Idaho beekeepers. It is electronic. This is the results from the last year, 2022-23 winter survival. The first bars show Washington State groups. The first orange bar is overall Washington State, 120 responses from beekeepers last year, a 36% level of loss. The other blue bars below that are Oregon State bee groups. The numbers to the left show the number of response. So there were 233 Oregon State responders last year. They had slightly lower losses at 30%. You can see for the various counties what the levels of loss were. The 7 respondents for Cowlitz County last year had a 23% level of loss, so considerably greater survival, less loss than the overall Washington State group. The survey is now open, so it's simply PNW Honeybee Survey, all one word, .com, and then you simply just click on Take the Survey. So if you've had overwintering colonies, I would encourage you to join, encourage others in your club. The survey is open through the month of April. So I open at mid-March and it goes through April. So here are the various groups, some of the local groups that might be involved on our talk tonight. What I do is I ask, how many colonies did you have in the fall by hive type? So Langstroth 8, Langstroth 10, nuke boxes, nuke colonies, etc. And that from that is computed. So this is Washington State losses for the 120 individuals. You can see the weighted average, in other words, the average level of loss is 36%. And then I do a great deal with that other information. And I also ask you some management things, mite control, particularly management. So I encourage any that have had colonies over winter to go ahead and join the survey. And if you have in the past, thank you, appreciate it. And I would encourage you to try to go on and record this information this year. This will be the 15th year of this survey. All right, we're into our bee season. We had a spate of nice weather, unseasonably warmer weather temperatures for 3 days here in the Portland area and across the region. Our seasonality of population is as they find sources for pollen after the winter shortest day of the year, near the end of December, bee colonies start expanding. So the queen starts laying eggs, in part to the increasing day length, but more importantly, the pollen income. And then by this time of the year, they are underway. They are starting to grow. So at the spring, first day of spring, also this week, depending now on how available pollen is, where your bees are, within cities, more pollen than elsewhere, the colonies will begin their growth. And then this quarter of the year, the spring quarter on until the longest day of the year in June, or our summer days, is when they will expand very rapidly. Now, what we are doing management-wise this time of year is initially checking for deadouts, and that's what I'm going to be talking about this evening. We want to try to keep colonies alive, and some of them are pretty weak at this time of year. If you've overwintered nukes, they, of course, are going to be weaker, but even some of your overwintered colonies are going to be weak. And so we might want to start stimulating weak colonies. We can do this in a number of different ways, give them something from the stronger colonies, but also do some feeding. As we get halfway decent weather, we hopefully will do a disease inspection in our colony. This is primarily looking to see, make sure that they do not have American foul brood, this obviously of the live colonies, not the deadouts. And then we want to determine the Goldilocks effect. So the Goldilocks effect is the colonies that are just right. Some of your colonies are going to be weak. Some of them are going to be strong. So what we're going to try to do with the Goldilocks effect is make them all just right. So we're going to try to weaken the stronger ones and strengthen the weaker ones with some of our management. And then as spring progresses, we're going to guide our development, try to keep colonies together if we're interested in honey production, if we need our bees and pollination service. And finally, of our last activity, one of the things that we can help to keep them from swarming is make sure they have supers on, so that incoming nectar, as the foraging becomes reliable, they don't put that nectar into the brood area, restrict the brood area even further. And certainly congestion in the brood area is one of those major factors that will lead to a colony swarming. So our spring is our busiest year of the season. Later, we're going to do the harvest after the nectar flow of summer, hopefully, and then bees are going to consolidate. And by 7, they have begun to hunker down in preparation for winter. So there certainly is a seasonality to our year. Here's what I mean by the Goldilocks effect. And of course, we're naming that after Goldilocks went into the forest and went into the cottage and found a porridge that was too hot, a porridge that was too cold, and a porridge that was just right, and ate it all. And so that's what we'd like to try to find, more colonies in the spring that are just right. So here is a beekeeper that does overwintering in a single box. The colony on the left is a 2-week colony in spring. You can see there are bees on only a couple of seams there. The colony in the center has bees you can see across the middle of the box and even extending to the bits of frames on the outside. And finally, the 2-strong colony in the spring is just already filling that box. Now, this beekeeper feeds dry sugar. So in the middle and the right boxes, you can see the dry sugar feed. The strong colony has eaten all of their dry sugar, or pretty much from the rim on top. The one in the middle has eaten at least half of it, a little bit more, and you can see they're feeding on it now in the photo. And the weak colony, they probably have consumed almost none of that sugar candy that we put on top. So management, we want to strengthen the weak colony by feeding them, boosting them. Boosting them means from the stronger colony taking frames of brood, cap brood primarily, and or bees, and transferring it to weaken the stronger colony and to bolster the weaker colony. The just right, the Goldilocks in the middle, we can't just ignore. We've got to watch their development as we go along. Now, one box management for swarming is a little bit different because you don't have the bees putting queen cells, swarm queen cells, on the underneath side of the top box. In other words, from the bottom, near the bottom bar of the top box. So you have to do some looking and management. And a number of beekeepers for a period in the spring will let a strong colony expand into a second brood area before they then eliminate it and put supers on top. So single box management, a little bit more difficult than double box. All right, deadouts. So that's one of our first activities. In the Oregon, we do not have a disease inspection service. So next week, I will be doing some more training for what we call task forces. And task forces are the groups of volunteers from local groups that when someone has an issue with their colony, some of the task force members will go out and look at it. So this was a task force effort last year. It's a tale of two hives. This beekeeper had two nukes that they established in spring. They were new beekeepers. They had not done mite counts. They had used oxalic acid in the spring, perhaps on the nukes. Well, not until they got the nukes, which would have been entirely ineffective, but that's what they used. And they currently had formic acid on the colonies. And so this was a call in October of last year. What they were concerned about was the colony on the left. They opened up the box and it just didn't look right to them. In the lower box, they took 3 photos of 3 different frames, and with their solicitation of having task force visits, sent us the 3 photos. They found bees in the top box where the formic treatment was. The colony on the right, they said, well, it's okay, seemed okay, bees coming and going. So task force went out and we took a look. So here's was the first photo they sent. Now, often we don't get the right photos, but this beekeeper took at least of the 3 photos, this is the first, the right photos. So here's the first photo. What does it show? It shows 2 brood areas, a very large brood area that just looks ugly. Very spotty brood pattern, sunken cappings, perforated cappings, just scattered brood, just not a very good looking brood area. And we believe what has happened is the bees moved away from that pattern because there were mites, lots of mites, and reestablished another brood pattern, much more compact, and the brood looking to be in much better shape. So that was a good diagnostic photo to help us decide that probably we're looking at parasitic mite syndrome. Too many mites in the colony, and the bees did not overwinter successfully. That's why they were thinking that there was a problem with this colony. The brood area moved, body pattern, particularly the perforated brood on left. Here's a second photo they sent of another brood frame. Again, widely scattered, perforated, sunken, discolored brood. We see instances where adults were partially out, the adults unable to emerge, But when we took a forceps or a toothpick, we could remove the brood. In other words, it came out. So at this point, we could be looking at American foul brood, sunken cappings, perforated cappings. But the fact that the brood comes out, a good sign, not saying that it's not likely going to be American foul brood. But again, the tale that we're going to read here is of some other things as well. The third photo they sent was this one, and this shows robbing. This shows honey on a peripheral frame and a lot of robbing. The bees have just torn at those cappings. There was a lot of debris on the bottom board, etc. So we were very fortunate to get 3 good diagnostic illustrations. So what did we learn and able to talk to the beekeeper about at the visit? The colony had left several frames. You can see some more frames there in the larger photo to the right. There's scattered brood, and particularly on that frame on the top where the bees have actually started building comb, contrary to the movement. You can see left and right on that frame evidence of robbing. And on that frame, and then particularly on a frame below it, you can see the ghosts of where these frames fit together, where they hadn't drawn the foundation on the frame below the top one there, but scattered brood. So very, very strong evidence of robbing occurring in this colony. The one, again, both of them had formicon. So we concluded that all the movement that they saw at the entrance, all the bee activity, was simply robbers. This was a dead hive already. There was no longer a brood pattern. There no longer was a queen laying eggs. Mites had done the colony in. But on our visit, as well as we see a task member looking there at the entrance, there was quite a little bit of entrance activity, but we concluded that this colony was the one that had done probably a lot of the robbing, maybe not all, but a good amount of the robbing, and in so doing had brought mites back to it. So although the colony was still alive with bees in late October, had sort of a badly organized brood area. The day we were there, it wasn't warm enough to cluster, but you could see where they would try to cluster. This was a walking dead, okay? Even though it looked very good, lots of bees coming and going, and even the one on the left because of robbing, a lot of activity. So unfortunately, and it did not survive the winter, 2 dead colonies. We did recommend picking up the one on the left right away, feeding the one on the right. It had the formic treatment on, but probably too late. And as I said, they did not survive. So 2 brand new nukes, 2 dead colonies, one in the fall, and the other will be dead by spring. Okay. So reading those deadouts. Another apiary, this happens to be a club apiary, 2 medium boxes of a brood area. The club goes out to look every month. In March, they went out to this colony. They saw a queen. They had an organized brood area. She was laying some eggs. It was a very small amount of capped brood, but almost no honey in the judgment. So the group decided to feed them, and so they did. They put newspaper down and then dry sugar on top of the newspaper. In other words, just granulated sugar. I am there in April at the inspection in April, and this colony is now dead. So a live colony in March, but weak. The corrective action taken, feeding dry sugar, it did not work. They were dead in April. We could have fed sugar syrup in March, did not, elected not to do so because we still have a lot of moisture in that time of year. And we decided not to add to the moisture stress in the colony, so instead fed them dry sugar. We could also have given them a sugar candy. We didn't have that handy. We had the dry sugar in March, so that was what was done. So the rescue did not work in this case. Why? You can see as I'm looking here, there was cap brood. So the queen was laying eggs. They were trying to rear brood. but they just ran out of food. They were not able to survive the weather that we had that year in the month of mid-March on to mid-April. These inspections are roughly done mid-month. Okay. I know you can't read all of this, so I'm going to go over why we find and what we might do with our necropsy and reading a deadout and trying to determine what is going on. We will often come up with things such as a colony starved to death. There were too few bees, they froze to death. We can get freezing of a larger bee group because they split their cluster and they're in two parts, trying to keep two parts of a wintering hive alive, and moisture issues. Okay, so those could be reasons that we'll take a look at. However, our major factor in winter losses, we estimate 70 to 90% of our winter losses are either mites, the parasitic mite syndrome, or indirectly from the loss of bees, or not enough honey stores stored, which is often indirectly because of mites. Now, many in my survey will say, well, I lost a colony to mice. I lost them to small hive beetle, sometimes, not so much here. I lost them to yellow jackets, the scavengers. I had a skunk visiting, and that's what killed my colony. That is a proximal loss reason, but it is not the reason you lost the colony. There are other things. So these are scavenger, these are opportunistic, mice moving in, small hive beetle moving in on a weak colony. They don't actually kill colonies. What we're reading is the end result when we pick up that deadout in spring. Something else has killed them. And then it's offered an opportunity to yellow jackets, to small hive beetle, etc. So that's where I am going with all of this, and I'll talk about a couple of other issues that can occur. So, determining a deadout or a colony in the fall that just, quote, doesn't look right means that we need to determine what is healthy. So here I have a frame from a colony and we need to try to determine, to answer the question, is this a healthy colony? We're looking at a colony that has capped honey in both of the corners, fair amount of capped honey there. We're looking at a large amount of capped brood with very few empty cells, that is, would be the blacker cells. But then we're looking at a part in the middle that is without brood. So, question, as you look at this illustration, is that healthy? Is that an indication that this colony is not healthy, particularly focusing there on the middle where there is no visible brood as we're looking at the illustration? Now, we have to look up close. There might be eggs in those cells. There might be larvae. But what else is our clue that we might look at to say that this probably is a very healthy colony? Well, one of the things we can be looking at are the bees that are ready to emerge. So there's a bee at the top, roughly 12 o'clock, ready to come out. There's a bee roughly at 10 o'clock, as you look at this as a clock face. A bee at 3 o'clock over here, just ready to come out. And on the bottom at about 7 o'clock, there's a bee that's got its head already out, antenna waving around. It's trying to get it, pull itself out of the cell. So why our diagnosis of healthy is this brood in the middle has already emerged, is already closed. And again, maybe there are eggs. The queen has come back to this part of this frame, or maybe she is not yet back to this frame. Why healthy? Because we're looking at the cap brood, very solid pattern, very few missed cells of those that have yet to emerge. Now, you can get up close and take another look. Now, there's another group of empty cells here that we might take a look and focus at. So I brought in another question mark, and this is this rim of 2 to 3 empty cells between the brood and the honey, or the very top bar. But you can see at the top of the question mark, the red one, you can see those cells are filled with honey. So why are those cells not with brood? Is this an indication of an unhealthy colony? Well, again, this is very healthy. Those cells contained bee bread at the time when those cells below it were at the larval stage. So the bees had the bee bread stored in between honey and their brood area, a very normal place to store it. And they've used up all that bee bread. You can kind of see that. You can kind of see how these cells are a lot yellower looking than, for example, down lower corners. That's because they had the stored pollen, the bee bread. So yes, very healthy colony. After we've done our interpretation of why are those cells in the middle empty and what's that rim of cells. I might also point out, by the way, that bees actually do not eat pollen that they collect, do not eat nectar they collect. They dilute the nectar and they make the pollen into bee bread. But in the lower corners where I just pointed out, so the lower corners below the capped honey, I'm at my pointer's at the right, my pointer's at the left, you can see cells that have liquid in them. So this is the honey that they have diluted, and that's what the bees will actually be feeding on, that diluted honey. If in doubt, take and do some detective work. So I have a toothpick. I've taken a larva out to me that didn't look in the right place, just didn't quite look right. So I pulled it out. I'm seeing if it's still alive. I'm seeing if it's off color. Seeing if there might be an issue that's occurring with the larva. Don't be afraid to do some of this sampling and check it out. There's a lot of bees where this larva that I pulled out came from. This one isn't going to survive, but there are a lot more. So don't be afraid to do some sampling. If you look at a frame that has open brood, you're going to might see something of this nature. On the 5 cells on the left of the insert are eggs, and on the 6 cells to the right, those are cells that have larvae in them. And I've got a question mark in the middle one that has the C-shaped larva sitting on a pool, and that pool, of course, is the worker jelly. And my question is this a healthy colony? Is all going okay with this colony? Now focusing just on the insert. And why I've got a question mark there is I want you to focus on that larva, on its pool of worker jelly. Is that normal? Does that look okay? And you should say, I'm not so sure. That larva should be on a pool of milky white food, milky white worker jelly. A big pool, much bigger than it is. And you can see that larva is barely on a pool, and the jelly is kind of clear colored. This is an indication of stress. Likely spring, likely older bees that have had to reactivate their hypopharyngeal glands, and they don't do a good job. And so these larvae are starving. There's not enough food in the cells. So that's an indication of stress. And if you look at the 5 cells with eggs, notice that you can really see the eggs. You can see the eggs because they're lying down in the cell rather than standing upright like the queen laid them, because those eggs are just about to seg over into more larvae. So the existing larvae look like they're being starved. There's not enough food. It's not really the right color, and certainly not enough of it. And the eggs are right behind. Those eggs are about to go to the first instar larva, and they're going to need food. And sometimes, as you see the eggs laying over, the food will already be in the cell. So the first 2, healthy. This one is an indication of unhealthy. So in our necropsy, that's where we start. Is the colony healthy? Are our indicators of cap brood, what's in the cells that might not look right, that we take a closer look at, insert right, and how the larvae are being fed, insert left, to make our determination. Is there stressor? Is there nutrition stress already in this colony? Nutrition stress, we know, will lead to the possibility of our spring diseases. So with this level of nutrition stress, this colony will have a greater probability of showing symptoms of European foul brood, perhaps of sac brood, perhaps of chalk brood as well, because of that nutritional stress. So we've looked at our colony. We need to know what's healthy, and we can make some determinations of what we'll do. What we want to do with this colony is strengthen them. More feed on the colony, and likely this colony, the insert on the left, could use a frame of just about ready to emerge adult bees. A nice full frame from a nice strong colony. Those young bees will emerge. They'll quickly become nurse age. Their glands will develop in a couple of days, and those will be the nurses. So those larvae no longer are faced with nutritional stress. Okay. So our deadouts. This is a time that we should have picked up deadouts. We had that nice weather. Had a chance to get out, look at your colonies. I hope you did. Illustration on the left, deadout colony. This is a different one from before. This one had a fair number of bees. You can see 3 medium frames have been pulled out. There were bee clusters on the 3 medium frames, so the bees were on at least 3 frames in spring. I've circled where the queen was laying eggs, and it already reached the cap stage. So you can see cap brood in those cells, but dead. The adult bees are dead. Now you have to be a little bit careful picking this up, because if you pick it up and they're right at that last stage of dying, I mean, they've just gone out of food, then you put them inside and they can, quote, come alive again with a little bit warmer temperature. They could be rescued with sugar, but depends how long they were dead by the time you got into them. Now, full depth frame on the right, this is what our dead cluster will look like. A good cluster of bees, a good number to cover where their queen is. If you see this on 3 frames, this would have been a just right colony had it survived. Here's one of those sides of one of those 3 frames. So neither of the frames that you see, none of the 3 on the left or the one on the right, the full depth, have any honey in them. So our diagnosis, real easy. They starved, okay? They likely did. We don't see honey, and where the bees are clustered, and if it's cold, they can't get over 2 frames where there might have been honey, still honey that you would see, that you might find it before it's been robbed. So it could indeed have been starvation. Another couple things to look for in starvation. So a different frame. Here's our cluster of bees, not as big as the frame, the past one. They're above stored bee bread. All the colors below are bee bread, of course. You can see right in the middle the queen, and you see bee butts. Okay, so there's that stored bee bread, but we don't see any pollen. Okay, there's that bee bread. Notice up here how they've strengthened this comb with propolis. You'll often see this. Notice the top couple 3 rows of comb cells. Not really good looking 6-sided cells, because they are compromised. Those are comb cells that are being strengthened at the top bar, and that's propolis that is doing that. Some additional information on this colony. There were some dead bees on the bottom board. There was some honey on other frames, not adjacent, but others. There was no mite treatment, or the mite treatment was late, like an October treatment. No mites were sampled, so we don't have a number of mites from any sampling. In some of the cells that did have brood, those above where I've just brought in this yellow box, had mite poop. And mite poop or mite guano, there's this white material often on the top of on the side of a cell on the top part. There was some capped brood cells, but not visible in this photo. So that left behind bees, those left behind brood, okay? So let's take a close-up look at this. I said we could see the queen. There she is. So I had a queen. Now you see all the bee butts. Look at all the bee butts. So bees were going into the cells. They were trying to keep warm. Some of them were heater bees, bees that would elevate their temperature above normal, and that would then help to serve. They particularly do this with brood that's in the cells. At this colony, this was an early winter loss. There is no bee bread, so these are the remains of the cluster. Some of the bees that were dead on the bottom board were the bees that were here that were trying to keep the queen warm, were on top of all those bees, the bee butts, the bees in the cells. So that's why you'll see some on the bottom board. So there's the bee butts, but no honey. So they're up where they should be honey. They should be right adjacent to honey. Off to the left, all the honey is gone. Off to the right, from the earlier photo, the honey is gone. So no honey. We do get spring starvation. Some locations are much more prone than others. In this case, the colony looks good. It's starting to expand, and then it collapses all of a sudden. So in spring starvation, compared to a winter starvation where the bees are still in cluster formation, spring starvation, we see the bees dying and falling to the bottom board. So this is a bottom board. Bees were actually piled up onto a couple inches onto the bottom of the frames. So this was a strong colony. You notice that there are bees all the way across the bottom board. This was our strong colony that came into spring, but they could not sustain their level of brood, and we got a cold spell. And a cold spell means they really cannot get out, rainy cold spell, can't get out to forage pollen for a period of 2, 3, 4 days. Depends how much honey stores were in the colony. One of the ways that you can help do check and see, maybe it was spring starvation, is check and see if you had nice spring weather like we had last week over the weekend, and then bees back, the weather back to winter, where the weather doesn't get even up to 50, cold, wet, rainy for like a 2, 3 to 4 day period of time. That's what will happen with a spring starvation. At this point, you will be able to see that even the frames on the outside likely don't have any honey left. So you will not see that. Now, starvation is not as common as believed. In my survey, again, this is the pnwhoneybeesurvey.com. I get starvation, weak colony. I get those as I ask you, what do you think your colonies died from? And I get a number of individuals that list those as possibility. It is really not as common an occurrence because often we look and we don't see honey, but it has actually been robbed out by the time we get into the colony. All right, another situation of a die out over winter. Much smaller cluster. Mold is set in, that's the white material. The pollen has already, the bee bread, the bee bread and bee brood has already molded. Those are all the white cells that you see. There are scattered cells that did not emerge for bees. They're scattered, they are sunken, they are perforated. They're really ugly looking. This has honey. There's a bunch of honey to the left. There is honey to the right, but there is no honey right where this cluster of dead bees are. So this is where the honey should be, right immediately to where the bees are. With that cold snap, they couldn't go that couple of inches over to where there was honey. Why? There just was not a critical mass. Too small a colony. So this colony froze out. It did not have enough bees to do the critical mass required to get through a colony. Colonies don't have to be big. but it depends on where the honey is and what time of year they get during the winter. They get small. Here's a colony. You can see there is new brood, but the bees cluster is away from the brood. So this colony was losing bees rapidly in the spring. They were losing bees rapidly in the spring due to mites. Mites affect how long bees live. And you can also see some mold. This was a colony that I inquired about, and this individual did not use any top insulation and had a top entrance on their colony. So this could be a colony that was too small, but likely as well, what has happened on this colony is the heat that was escaping from these cluster of bees went up to the top surface, the inner cover surface. The cover was not insulated. The inner cover was cold, and so the moisture condensed on the inner cover and rained back down moisture onto the bees. The droplets got bigger and bigger, and the moisture rained down on the bees. And so you can see the effects of moisture, particularly here on the bees, outer bees of the cluster. They've already started molding. So in this case, the failure to have a nice insulated top and also having a top entrance, perhaps we could make that diagnosis that there was too much moisture, and that then affected the longevity of the bees. And the winter went on just too long, too much moisture, and the bees were not able to survive. So we do have some starvation. We certainly have colonies that are too small. And moisture is one of our number one issues in terms of some of that loss. However, the number one loss is mites, PMS, parasitic mite syndrome. And this would be what a deadout would look like. So we pulled out, this looks like a middle frame. So this is where the bees should have been clustered. There isn't a cluster, but there is brood. There's a fair amount of brood left over. Now, this was brood that was being reared by the colony in the fall. And particularly, you can see the brood around the edge. I will label that the ring around the bathtub effect, ring around the bathtub. What happened is the bees had mites. They were not living as long, and they were getting closer and closer together with their cluster, and they actually left the brood area. There were not enough bees to keep a brood area warm. And so in the fall, they were condensing their cluster as the nights got cool, and they left brood. Every one of these cells could have been an adult bee that helped keep the colony alive during the winter, but they didn't hatch. They didn't come out as adults. So these were lost bees that could not help the colony over winter. Notice there is still some honey left in the corners. Not a lot, but enough that could certainly help them out. So parasitic mite syndrome, there's that honey that I'd indicated in the corner. Here's a lot of honey on this frame, but look at that brood area. So nice brood area. The bees should have been clustered over that brood area. They are not by the time we discover the deadout. And all these capped brood cells that did not come out as adults could have been adult bees that could have helped the colony get through the winter. So what we will see with PMS in the spring. Lots of honey in the colony. There's not starvation. Perhaps too few bees, a very small cluster by the time you found it, but look at these frames that the brood that didn't help them get through the winter. And that did not because of the issue with mites. Very classic parasitic mite syndrome deadout, okay? So we should use our inspection skills in the fall to start seeing what is the stressor for the parasitic mite syndrome. Several are shown here. One, I have not brushed the bees off this comb. So this comb just came right out. And you'll notice first off, there's not enough bees to cover the brood area. Not enough adult bees. So there's already in the fall a low adult number. And fall, I'm talking early as September, maybe August, September certainly, October for sure, okay? Look at the brood pattern. Now, the pattern immediately to the right, the last part of the pattern looks pretty darn good. That's a nice solid pattern. But look at the pattern through the middle, a very spotty brood pattern. We look at larvae and we look at a condition we call snot brood. Very descriptive. The larva is not alive. It's off color. It's grayish. It's often out of position. It's not a nice tight C-shaped curled larva. It's somewhere else in the cell along the side, somewhere else, what we call snot brood. We will look as we brush a few bees away, we're going to see uncapped cells. And as we looked in those cells that are the spotty brood pattern, we're likely to see mite poop. So not one character we're looking at. Lack of adults should have been immediately a clue to have us take a closer look at the brood, see if we're seeing this spotty pattern, seeing larvae that are not healthy, seeing this uncapped cells. So I'll show you that. Some colonies, the spotty pattern just hits you in the face. This is a spotty brood pattern. Okay. And this happens to be for bees that, hygienic bees. They're not removing them. They are removing some larvae as the brood doesn't get to the cap stage, et cetera. That's why the pattern is spotty. Okay, and leftover capped honey. So let's focus on a frame that has this very characteristic parasitic mite brood syndrome. I've added another B in there. Parasitic mite brood syndrome, because we're looking at the brood. We're going to look at the brood here primarily. Or what has also been labeled as idiosyncratic brood disease syndrome. That's 4 words to say, I don't know what's happening to brood, but it's not healthy. Something's wrong, okay? Idiosyncratic is we can't pin something. It's not because of A, B, C, D, or E. It's because of X, Y, Z, the unknown, okay? So, spotty brood, looking where this should be a solid pattern. It will be more condensed in the spring than in the fall than in the spring, but this should be spotty. You can see that it's not. The hygienic bees are doing their work. So look at these cells that I've just circled. You can see there's 3, 4, 5, 6, 7, 8 cells that have been uncapped. So out of about 25 cells, 8 have been uncapped. So the hygienic bees are doing their job. They're uncapping a quarter of the cells. But when they uncap, they are pulling out the pupae. So these are pupae that will not survive to be adults. And so this colony will not have adults to be able to let it survive over the winter. Not enough adults to be able to do that. Hygienic bees can't tell of those cells which one has the mite in it. They can detect the mite, reproducing mite. So they are uncapping a bunch of cells looking for the mite. When they find the one with the mite runs out and they yank out their developing pupa, their developing sister. So they finish that mite in that reproductive cycle, but they are also finishing off other bees that are healthy as they're doing their uncapping. They can't tell exactly which cell. They know one of those cells, particularly in that group on the top, those group of 4, they're uncapping 4 cells, looking for maybe only one that has a mite in it, okay? Now, some bee groups recap. And so there's a group here of 6 cells. The lower 3 look like they've got a funny looking surface on them, on the capping. And these are likely a recapping. So these cells have been recapped by the bees. I mentioned snot brood. There's 2 of the 4 cells circled at the very bottom board here that are snot brood. And even without this being a close-up, you can kind of see that as you look into those 2 open cells of the 4, look at those are gray. the larva is not a nice tight C shape. So this is a larva that's out of place, out of color, and is dying. That's what we call snot brood. It's not European, it's not chalk, it's not sac, it is something else we don't know, and hence often the name the IBDS, idiosyncratic brood disease syndrome. We can also see there's low adult bee coverage. Bees that are moving off the brood area already, they are starting to condense, move into a tighter area as nights get colder. And as they're doing so, they're moving off a brood area. So even though some of these brood cells are not uncapped, they will likely chill. And for that reason, they too will not produce an adult bee that's got to live the 5 or 6 weeks, 6 months of winter to survive winter. Okay. They will often cannibalize brood. So there are some yellow arrows at the bottom. These brood are in the normal position. They were C-shaped. These are actually uncapped cells, so these are pupae, but the whole pupa is not there. So the bees are cannibalizing. So these again could have been adult bees that could have helped them get through winter, but because of mites, they do not. Okay. Cannibalizing brood. I thought I had one more. So, quality control, hygienic bees, they're doing what they need to do, checking on disease cells, removing that snot brood, removing mites from the cells, but too much of this, of course, and that's why we don't want purely hygienic bees. They would just clean out house too severely and still not survive winter. This illustration and another lovely 70 of them come from a book called Do You Speak Bee? A book that is just about to come out. I reviewed this in the April American Bee Journal, if you get the American Bee Journal. A lovely book, lovely illustrations. All right, now, a couple other things we might look for if there are still live bees, particularly in the fall. So, it is not the mites. I've been talking about mites being responsible for the colony dying. Yes, the mites are responsible for the colony dying because the mites are enhancing spread of 2 groups of viruses. On the left, deformed wing virus. And I've circled 3, Robin has circled 3 bees there. Those are adult bees, but they don't have functional wings. So these bees are not going to help your colony get through winter. So they weren't cannibalized. They got through to the adult stage, but because there were mites feeding on the developing pupae, the bees came out without the ability to have normal wings. What it is the mites are dirty hypodermic needles. All right. What has happened by feeding on the bee directly on its hemolymph and fat body, the mites puncture through the exoskeleton of the bees. Now, if the bee happened to eat a virus, got a virus from a sister, it would go through its digestive tract. And bees have some immune system, and their digestive tract would try to neutralize those virus particles. However, in the case of mites, the mites have bypassed the digestive tract. The mites have stuck their dirty mouth parts right into the bee, and in so doing, in the bee's body, as it developed in the pupal stage, this group of viruses was favored, it took over, and it reached epidemic proportions. And by the time we see even one deformed wing virus bee in the colony, that virus then is rampant and has a chance to take the whole colony down. The other virus complex are the paralysis virus complex. On the right is a black bee, but not a normal black bee. It's pretty hairless and it's shiny. So this bee has what we call chronic bee paralysis virus, CBPV. And this also has been enhanced by the dirty hypodermic needles of mites feeding, perhaps on the adult, but also when they're feeding on the fat body of the adults or on the developing pupae. And so this group of viruses, Israeli, chronic, acute, reach epidemic proportions, particularly the Israeli and the acute bee paralysis virus, and that takes the colony down. So the colonies are actually dying from a virus epidemic, but it's because they have been fed on by mites that bypass their own individual bee immunity system of their digestive tract. What's happening here? So here is a whole big bunch of bees that failed to emerge. Remember, I talked about that. Upper right, you can see cap brood, looks pretty good, but a whole bunch of bees that did not emerge. What's happening? Okay. Is this a disease? Is this a stressor? This is actually the effect of our treatment for mites. We see this with the plastic apivar, the amatraz strips, but this was not. This was, the individual was using Hop Guard. So they took the plastic, the cardboard impregnated strips with Hop Guard, laid it over the top bar so it went down on both sides, and a cap brood that was underneath that Hop Guard strip all died. You can see they were not able to emerge. Okay, so we sometimes get some unusual situations. The Hop Guard strip was in contact with the brood, and eventually this becomes the bees will pull this out, and in so doing they'll disrupt the cells underneath, and particularly with the apivar we'll actually see a ghost patch where the cells are indented, where they've had to dig out those dead pesticide killed bees. So fall, spring, recap, few adults, no dead adults frequently with the PMS, or very few, very few. Scattered, leftover, sunken, perforated cap brood that you see here, just a real giveaway. Chewed down pupae. In this case, they moved away from this, and so the pupae just died from cold. Adults unable to emerge. There are some examples here. The big thing that you need to do on a dead out is take a toothpick, forceps, tweezers, and pick bees out. If you can pick on any of these random cells and the guts inside, what's left inside, the dead developing pupae, the dead adult that couldn't come out, if you can then remove it. So here at the end of the toothpick, here was a pupae. We've removed it. You can see it's come out. That's a sign, a good sign that it's not going to have been a dead out due to American foul brood. And then look at the color. If it's off-white, grayish, that's that snot brood color or just simply decay color. If it's yellow or not yellow, or not twisted in the cell, that would have been an indication of European foul brood. We will see it in the fall, more likely come spring, you'll see it. And particularly if it does come out, if it's not what we call ropey, gooey, you just can't get the remains out of the cell. It just will not come out in one piece. That is an indication of American foul brood. You need to do a couple of other looks, another more examination. But if it comes out, that's a good sign that you're looking at these dead brood that the bees had to abandon because there were too many mites, not enough adult bees to cover and take care of all the brood to raise enough brood to get through the winter. All right, I mentioned very earlier these other secondary things. Well, there was two mouse nests in my colony. They must have killed my overwintering colony. No, we'll see shrews. We'll see some other things that go inside. They're just taking an opportunity of a weak, dying colony. It's probably a PMS colony. The mouse is just moving in, and it can feed on some of those remains. So it's got food and shelter. Good place to live during the winter. Skunks, yes, they will weaken a colony, but they will find the weaker colonies to begin with. So they are your early warning device. If you see scratching on a colony, scratching on the ground, you see the curds of skunks, you have a weak colony. So that if you want to have a chance to get it through winter, you've got to make it stronger to have it get through winter. The skunk isn't going to kill it. It's going to help weaken it, but it's weak for another reason. Sliming of frames. Fortunately, we're not seeing much of that yet on the West Coast. We'll see. We're seeing more and more common where a small hide beetle is common. What that small hide beetle is creates its own environment, and the bees don't have the use of all of the honey. The small hide beetle are sliming it, making a fermented honey, making it into a slime, and they live in the slime. They're perfectly good in that slimy mess, but the bees hate it, won't go into it, can't get at the bees. So they don't kill the colony. It's already a weak colony. There's some other issues. And likewise, heavy yellow jacket predation. They're predating on the weak colonies. They didn't kill the colony. They help weaken it. They helped it die in November, December, rather than maybe it surviving to this month, February or March. They don't kill colonies. So necropsy, mostly all about the mites, mostly about this parasitic mite syndrome. And again, it is not about the mites. It's about those dirty mouth parts that puncture the developing pupa in this case and inject into it. And that enhances the growth of these two groups of viruses that actually then reach epidemic proportions, and your colony actually dies from the viruses. Now, returning back to the other topic, spring. So in the colony and spring, we've got to manage two populations. The blue line shows our normal progression of our honeybee colony. And right now, they're very early spring where the arrow ends. They're beginning to grow from their weakest portion. They'll grow very quickly in about 3 generations. A generation's 21 days. So in about a month and a half, they will then have a very populous colony. And in that populous colony, then they will then reach a sweet spot where it's convenient for them to reproduce. Now, when the queen lays eggs, she's populating her family, whether they're fertilized eggs for workers or now the unfertilized eggs for drones. But colony reproduction is the process that we call swarming. And colonies, as they get big, as the season gets favorable for resources coming in, things get congested in the brood area. Lots of mouths to feed, so there's a lot of nurse age bees, lots and lots and lots of bees. The chemicals of the queen do not get efficiently distributed, and then the queen reads that as it's time to raise more queens. And in the spring, that usually means swarm cells, and so that sweet spot of the population growth. If we're going to do something about swarm control with our bee population, what we're basically trying to do is delay swarming so that the bees will supersede that queen later in the year. What we're trying to do with swarming is keep enough bees in some of our colonies that some colonies that have enough bees will store surplus. We may take a divide. We may make a brood area of 2 parts in the colony. There's a number. We may take the queen out for a while. There's probably 50 variations of what you might do about swarming. However, the other population that we now need to be considering now, March, and certainly April and May, is this orange population. And the orange population represents the varroa mite population. So we're not just bee population managers and guiding their population. We need to also guide mite populations, and we must manage them as well. We have been doing that at the back end. We've been doing that when the supers come off in August, maybe September, and September and October, when the bee population is decreasing, but the mite population is still increasing. And the mite populations will actually peak later than the bee populations. So you see the blue population peak, that's the bees, but the mite population, just to the right of this second circle, is when they will peak. So that's the hardest time of the year. That's the toughest time of year. That's often too late in the year to think about mite control. Managing mites means this time of year, now, as the mite populations go from their lowest point and the founder's mites start going into pupae and start reproducing. Now, as your colonies raise drones, and beginning at that arrow of the bee populations, about the time we have a number of colonies that are already raising drones. You might see some capped drone cells already. The mites reproduce early in the season in the drones, not in worker bees. They reproduce in the drones. And the drones, as adults come out, and the mites are on the drones, at least initially. The mites move around. They will go to a worker bee. They will feed on fat body of a nice worker bee that hasn't expanded all of her fat body. They'll find those worker bees that still have some fat body, feed on that, and then go back to drones. And then they'll go back to a nurse bee often because they're going to look for a cell to go into just before the capping. And that cell in this time of the year will be a drone cell. So we need to do drone management to be effective, not wait to the end of the season when the supers come off. Now, so that could be chemical, it could be drone removal. But the operative lesson is now we got to get some weather so we get back in our colonies. But certainly you need to start in April, not wait to August. April, not now. Question we need to ask of our colonies, not colony, do you have mites? No, that's not the question. The question we want to ask is how many mites does the hive have? And unfortunately, we don't have a way to give you an answer. If you take a sample in April of 300 adult bees, the colony is getting bigger. There's a lot of adult bees growing fast. You will not find mites, or maybe you will find one mite on 300 bees. Does that mean your colony has few mites? The answer quickly is no. It is not effective sampling the adult worker bees because the mites aren't there. The mites are in the drone brood reproducing. So if you uncap some drone brood, and the problem is it's not just any drone brood, but they are clumped. So you might have drone brood in your spring colony, let's say on 3 frames, or on the brood in between the frames. But the mites are not going to be randomly distributed. A few on this patch of drones, a few on that patch of drones, a couple on this other patch of drones. No, we now really understand mites are not randomly distributed. So a random sample of 300 adult bees, you don't find mites in spring, in April and May. Why? Because the bees are not randomly distributed on the worker bees. And if you only uncap a few drone cells and you don't see mites, then oops, the assumption that we don't have mites in this colony is incorrect. If you uncap about 50 drone cells from different places, and I recommend 3 or 4 different places where you might have drones. If you uncap and you find as many as 2 or 3 of the cells of capped drone cells. So the way you do that is you use a capping scratcher, you impale the drone cells, pull them right out through the capping, look on the underneath side on the bodies. If you see 2 or 3 that have mites on them, then you should be starting your mite treatment. You should be doing your mite treatment. 2 or 3 on drone brood selected randomly from where they're rearing drones is a bad sign. 1 or 2 on 300 adult bees doesn't tell us anything really at all. Now, this is all new information, so some of this may be unfamiliar to some of you. And we're going to be hammering it, trying to help us illustrate where they are. How do you understand some of this? This is from the Honeybee Health Coalition. This is the book, one of them that Margot introduced, said that I have been responsible for. This is Tools for Varroa Management. And we do talk about sampling, particularly sampling also for drone brood in this new edition. Be an optimist. I can do it. I can control mites. I can control swarming, or at least some of it this year. I can control some of the mites. I can do it. By the way, here's a product. I don't know if any of you use it, and I hate to discourage you from using it if you're using it and you like it. This is complete. This is a complete diet. And if you look at what's on here, there's everything. There's Nozavet, which is Nosema, sold as Nosema. It's completely ineffective, but it's sold for that. It has Optima. It has Pro B. It has Pro and Pre and Probiotics. This is $22 of snake oil. Totally worthless. It is a very expensive 8 ounces of sugar syrup. Beware the magic bullets. It takes work to control mites, to control swarming. Finally, some things that I might recommend that you go to the bees and do your inspection with. Gloves, forceps, toothpicks, or nails work just as well. A capping scratcher. Make your mite counts at least later in the year. The diagnostic kits, they're $15. That's a little pricey for that test. They can only be used once. But if in doubt, from your field of symptoms that you're looking at, it's a good thing to use. Flashlight, magnifying glass, so you can really see. And take a record book, because if you happen to take a sample and send it off to WSU, send it down to Oregon State, you want to know when the results of that sampling come back, what county you took it from. Of course, you're going to remember it was from this county or that county. Of course, you're going to forget that too. Okay. And then containers, containers that you pee in at the doctor's office, or vials, plastic baggies, whatever might be the case. A good toolkit for your disease diagnosis. I have reached the end of the information I wanted to try to present. Should we, Margot, should we go back to screen sharing or leave it on this slide? I indicated if you do not get an answer, here are my 2 emails. Send your question. I'll try to get an answer. The survey, I should have put that back on one more time. PNW Honeybee Survey, all one word, no caps, .com. Click on the top bar, take the survey. And I hope you will tell your friends. This is the 15th year. I'm going to do a deep dive of the information. Information is available on the website. The same website has all the survey results. And so you can go on and look. The Olympia Beekeepers, the Puget Sound Group, Cowlitz, Clark, they always send in Clark, Lewis, always good numbers of samples, and I appreciate that. And I'd like to get some others from other members in Washington. I'm done.
From this side, we've only had a question about your email address and a survey in the chat.
A survey in the chat?
I'm sorry, to put the survey information in the chat, which I've done. So
thank you, Margot.
Here's another one. Could you discuss nosema versus diarrhea? How are these two things related?
Diarrhea is bad food, and we see spotting on the outside of the county. Nosema is a microorganism that lives in the digestive tract and it robs the bee of its nutrition. And when it reaches high numbers, more than what we call the equivalent of 1 million spores per bee, that means it is sick in the colony. Unfortunately, for nosema, we do not have any good symptoms, any good signs, signals. We actually shouldn't use the word symptom. That's a human term. We don't use autopsy. We use necropsy. So signs or signals. The spotting on the brood of the the boxes, the covers, laundry you've got out on the line, cars in the driveway, the side of your house. That's food. That's food related. That's not nosema. Unfortunately, nosema, we do not have any signs, any signals. And unfortunately, our antibiotic treatment, excuse me, that we used to use of the antibiotic fumagillin, it cures the bees initially, but then it comes roaring back worse than it was that had you not fed the antibiotic. So nosema, it occurs in less than 5% of the colonies. It shows up as weak colonies, colonies that don't develop normally, colonies that won't give you a honey crop, just colonies that limp along in the spring, limp along into summer, never get big, strong enough. And that could be mites, it could be diseases, it could be any number of things. So there's no sign or signal, unfortunately, that really show us a colony has nosema levels. If, by the way, you do feed fumagillin, less than 5% people do, don't stop feeding it, but check your colony. If you feed it and then you think the colony goes downhill afterwards, I would suggest that what you've done is you've actually made the condition worse by feeding the antibiotic. The dysentery will clear up. Better food, better foraging. Bees go a little bit further away to poop. So it will clear.
We have one question from our Zoom. What is the product you recommend for mite treatment in the spring?
So 3 things will work. Apivar, the amitraz, for most of us with only a few colonies, most of us that haven't been heavily buying nukes or buying packages, the Apivar, the amitraz plastic strips will work. It's the gold standard. You will have to wait 2 months. So if you started feeding it this week, before 2 months, you would not be able to put supers on the colony for 2 months. It's a long time. So many of us will use that treatment in the fall after the supers come off. In the spring, if you think your colony by sampling the drones, or you do a worker sample and you have a high mite number, if you think the number of mites is high, you didn't use oxalic acid over the winter, for example, so they came into the spring with higher mite numbers, then the best treatment is formic. Formic has a lot of collateral damage. It kills brood. It stops queens from laying eggs for a week or so. But in the spring, colonies will recover from that. Even though the queen hasn't been laying eggs for a week, they will recover from it. Use the 1 pad treatment and then put the second pad on. Don't put the 2 pads on at the same time. Once we start getting days that get into the 60s, the thyme oil treatments, the essential oil, thyme oil, is a good choice. Thyme oil is sold as Apivar, the gel. You put the gel on the top bars, it then dissolves and the fumigation kills mites. Or the Apalife Var. This is a wafer, a strip that you break into 4 pieces. It has thyme oil as the major essential oil and has 3 others. When I do the survey, I ask, what do you use? And it turns out that not the people that use either Apivar or the Apivar Life, which is the other thyme oil, they are the people that consistently, year after year after year, have fewer levels of losses. So I ask the question, what do you use? And then I look for those that say they use Apivar. I look at the number of losses that those people had compared to the overall average loss. So for example, in Washington State last year, overall level of loss was 38. Overall level of loss for those individuals that used ApiGuard or used ApiLifeVar was down in the 20s or even the teens. Overall loss. So those were the individuals that had better survivalship, lower level of loss. So those are good products, but it's still just a little too cold to use it. It works best roughly in the temperatures 65 to 85. You can use it at 60. So if the daytime temperatures get up to the mid 60s and the nighttime temperatures are not dipping way down into the 50s, the upper 50s, that's a good time to use the thyme oil. And drone brood removal. Use the capping scratcher. Be unmerciful. Kill as many drones as you can. Cap drones. Use the capping scratcher. Poke every drone you see that's in the capping stage. Pull them right out through the capping and throw them away. Okay? Throw the pupae away. In so doing, you will find that pod of drones that have more mites. And in so doing, you will be able to remove that pod of drones. And you found how the non-clumping drones are. And every drone brood, every one that you remove now in the spring with a mite in it, you have stopped that mite from growing the mite curve. So the curve will not grow as fast and will not reach as high a point. So Apivar, Formic, the Formic Pro, for example, the 2 thyme oil products, or certainly recommend drone brood removal. Strong colonies, if you separate them, you can do some treatment with oxalic, but only the parts that have that you split that have open brood. Oxalic is a very poor tool, very, very poor tool to control mites in the spring. Very poor. It doesn't do the job. There's just too much cap brood. And so if you create a split that has very little cap brood, use oxalic in there. Dribble it in. If you prefer the oxalic vaporize, treat that. So brood breaks, drone brood removal, by far the best, easiest, and most effective way to control mites this time of year. This time of year being April and then May.
Okay, there's a couple of more questions here. The one that's pertinent to what you were talking about right now is thyme oil different from thymol?
Thyme oil is thyme oil.
Okay, so that's the same. And then second question, and then there's a comment, is do you have any experience with unhealthy brood odor for testing for hygienic behavior?
There is a product out there, UBO, that is being sold as a device for people that are producing nukes, for example, packages, the queen breeders, a nice handy product for them, so that they can determine which colonies are doing a better job in detecting the real odor of the mites. Do I have any experience with it? No, I haven't bought it yet. It's not really for us. It is really for the producers of bees and queens.
Okay, and finally, there's a comment from Bree Price, who is the WSU Extension Coordinator. She wanted to let you know that WSU doesn't currently have a diagnostic lab. And unfortunately for Washington beekeepers, OSU only accepts samples from beekeepers in Oregon at this time. So WSU, or Bree, says that they're recommending that beekeepers send their samples to the Beltsville Bee Lab in Maryland. It's free, and it's easy to find information on how to sample and where to send it if anyone wants to. They can Google the Bee Lab in Beltsville.
Yeah, so you use your search engine, how to send a sample to Beltsville Bee Lab. It'll come right up. Mainly, you don't want mold to grow, so you don't want to wrap it so that mold will grow. So USDA, Beltsville, Maryland, free service. They will look at that. They will not do a virus analysis, but they will look for brood diseases. They will do a mite count on mite samples then as well. Yes, I'm sorry for that misinformation. I really apologize.
Oh, you didn't know. It's been gone for a few years now.
Oh dear, I'm way
So
behind. Okay.
anyway, it looks like we might have one more here. Oh, no, mostly just thank yous. It was a very interesting presentation. Basically, after all of these presentations, it's like control mites, control mites, control mites.
Isn't that the truth? Isn't that a sign of the time, huh?
Yeah, so
Boy.
anyway, we'd like to thank you very, very much for giving your presentation. This will be posted for anyone that's interested on Ask a Washington Beekeeper Facebook page. So if you know someone that missed the presentation tonight and would be interested in it, you can direct them to our Facebook page.
Okay. Yeah.
With that, I'm going to say good night to everyone and thank you for joining us. And we will be back in April, the third Thursday in April, with, I hope, a panel of bee experts to take all your questions related to bees. Very appropriate in April because it's package day soon. So.
Okay. Can I give an ad at the end? I talked to Puget Sound next week. And then the first week of April, I'm talking to Olympia, the Northwest, Skagit, Stanwood, Camino. So I hope to see my good Washington friends at one of your local meetings and Lewis County, I'm sorry, as well. So.
Wow, you get around.
Yep. Thank you, Ken, and Collins, the Collins group. I was planning to come up and join you at the Sons of Norway, but thank you for agreeing to go on to the Ask a Beekeeper program tonight. Margot,
Yes,
thank you for all your arrangements. It was very, very efficient on my part because you did all the work and got us going well.
All right.
And Ellen and all, thank you. Thank you to Bree for the information.
Well, thank you, everyone, and good night. We'll see you next month, I hope. Take care.
Hope you. Yeah. Take care.
Thank you for having us join you tonight.
Okay. Okay, Ken.